Hello everyone, welcome back once again. Today we are going to learn NAT concepts. So in the previous session we learned about the security policies. Once we are quite good with the security policies, we want to move towards NAT, and I want to tell you that how NAT is configured in Palo Alto Firewall. But before going to practically being configured in the firewall, I want to tell you that what is theory running behind this NAT and why exactly we need NAT. So the first question comes like, why NAT is important, right? So this is going to be a theory session, and next session will be on the practical demonstration I will take, because if I take it together then it is going to be a bit long. So the very first question, that why do we need NAT? So the answer of this question is behind the concept of IPv4 and IPv6, right? You know that there are two versions of IPv4 and IPv6. So you know the story, and if you don't know, then let me tell you the story that in IPv4 version, that is a 32-bit address, and with that 32-bit address, it was not possible to get IP address for everybody in the earth. Means that our IP addresses were limited. It was not possible to give IP address to all. Now the problem was come that internet was evolving, and every user, whatever the if you are a normal person, you are using a laptop, and then you're also using a phone, you might be using an IPTV, or you can say the smart TV, and every these equipments need an IP address. And even if that is a large enterprise, they might having thousands of cameras installed in their premises, and every cameras need a IP address. So the problem was that even a single user was using multiple IP addresses, and these IP addresses were going to be ended. The solution was to switch to IPv6, but all these hardware devices were not supporting, right? Whatever the hardware we have implemented till now, those were not uh, comfortable with the IPv6 address, so they need some modification to support this IPv6 address. So now the problem was that how to move forward, because the IPv4 addresses were limited and we are not able to use internet. So the solution was to this one, that we use the concept of NAT, and that stands for network address translation. So what happened that we used two types of IP addresses. The first of the IP address was private IP address. Let me change the color. The first was the private IP address, and another type was the public IP address. And if you are good in the CCNA, and then you might be good at it, public IP, because these are the concepts of the CCNA. But I'm getting you going through once again, because if I do not tell you and you don't know, then you are not able to configure the NAT in the firewall, and then my session will be waste. So that's why I'm telling you these things once again. So the private IP address ranges from every subnet. There starts from class A 10.0.0.0 to 10.255.255.255 something, and 172 dots, that is a class A. So in every class we are having the private IP addresses and public IP addresses. So these, whatever I am telling you, these are the private IP address range, and these are the private, and you know it, right? And if you don't know, then just search in the Google, you will just get everything. 16.0.0 from here to 172.16.255.255.255. And same thing is with the class C IP address. They starts from 192.168 10.1.0 to that's all. So beyond that one, that is up to this range only, and after that 193 is the start of the public IP address. So only these ranges are private. X out of this range, everything is public IP address. So what we are using, let me clear it out, clear all. So what we use normally, that let us suppose this is an enterprise network. So here we are having the multiple computers. So inside the enterprise, whatever the user it will be, they will be using the private IP address. Private IP address means they can be using like 10.1.1.1. Similarly, it might be like this is an enterprise 1, enterprise A. Similarly, an enterprise B can be, and that can be also having multiple computers, but that can be using the same IP address. They can reuse these IP address. Let us suppose this guy is also using 10.1.1.1. So this was the benefit of using the range of private IP address and public IP address. Now this is just happening in the private world. Like this is within the enterprise. Whenever you are inside the enterprise, then only you are using the private IP address. But what happens that when you are going to the outside, you want to access the internet. So what is happening now, this private IP address was translated to some other IP address. Let us suppose it is being translated to 20.20.20. So whenever inside it is using this IP address. Whenever it is communicating from this machine, so it will use this IP. But if it is going out of enterprise and communicating with another user, any web server, right? Let us suppose this is in a Google server, and if we want to communicate with any of the Google server or gmail.com, then he will use this IP, and then it will go to Google server. But the problem remains the same, right? There now, if you think of that one, there are three types of the translation. That is a static, another thing was a dynamic, and next thing is our port address translation. And sometimes we also call it as a PAT. So what happens with the static? In case of static, IP to IP mapping was done. Statically we define it that if this user 10.1.1 wants to go to the internet, it is like we are having the table here that 10.1.1.1, if it is going to the internet, he will statically use 20.20.20.20 to the go to the internet. If 10.1.1.2 wants to go to the internet, he will use 20.20.20.21 to go to the internet, and then he can go to the internet. But the problem was this use with this IP to IP mapping, that whatever the benefit we were thinking of saving the IP addresses, that was not working, right? We were having one IP address, and again we are reserving one of the IP addresses. So this thing was not so popular. In fact, we can say that it was not giving the proper results. So what happened, we went to the dynamic. So in case of the dynamic, what happened, we took the, let me change some other colors. Okay, let me take green. So in the case of dynamic, what happened, they had some pool. It means that let us suppose we are having 3 members. Let me clear it, I don't have the space now. So what happened that let us suppose we are having 10 users from 10.1.1.0 to 10.1.1.1.1 continuously 10.1.1.1.10. So these are 10 members of one enterprise. Enterprise means we have the one company, right? So enterprise A, and that is having 10 computers, and they want to go to the internet. Now what happens that we are having the reserve pool of 5 IP addresses. it could be like 20.1.1.1.1, 20.1.1.1.2 continuously. It might be up to 5 IP addresses only, 20.1.1.1.5. So in dynamic mapping, what was happening, that if this user, the first user wants to go to the internet, it comes this, it takes one IP address and go to the internet. Now one IP address, this is the public IP address, and the first one is our enterprise is a private. So our one of the IP address is utilized. Now this user wants to go to the internet, he used this IP address and goes to the internet. Benefit of this was, let us suppose any of the day or the during the time, one of the member 10.1.1.1, in this case what was happening, only 5 users from this machine can go to the internet, because we are having the available pool of only 5 members. But the benefit of this was like, we don't have static mapping. So if any of the user is absent here, then another user, let us suppose this guy, he can use any available IP address and go to the internet. What was the problem with the static? If one we done the mapping from 0 to 1, let us suppose leave 0, 1 to 1 mapping is done, and 1.2 was assigned to this, 1.3 assigned to this, 1.4 assigned to this, 1.5 to assign to this. Now users from remaining IP addresses 1.6, 1.7, 1.8, 1.9, 1.10, we don't have any static mapping for that one, and they will never go to the internet. But it's still the problem somewhat solved, but it was not completely resolved. The solution of this was basically, which was saving the internet, that was PAT. That was port address translation. What happens in the PAT? Any of the user who is having 10.1.1.1, 10.1.1.2, 10.1.1.3, it can be multiple IP addresses, 10.1.1.100, and now they want to go to the internet. So what happened, we took just one IP address, let us suppose 20.20.20, and if this user wants to go to the internet, then what is going to happen, we take this user like this, it goes to the internet. But what happens, that while going to the internet, it changes the port. So going to the internet, it uses this type of things, 20.20.20, and then at the end it uses this colon and uses some port number. Let us suppose this is using the port number 6321. Now if when this user wants to go to internet, it will use the same IP address of this pool, but at the end it will use some other port number, 20.20.20 colon 6322. These ports are the random ports which are picked while going to the internet or going to the outside. It might not always happen to the internet, but whenever it happens, it takes any random port and goes to the internet. So again, if this wants to go, it will take 20.20.20 and take some random port 65432, right, and it will go to the internet. So if you observe that we are using only one IP address at this time, and you know that the port numbers are from 0 to 65,536 something, right, while port from up to 1000s are reserved, but still we are having around 64,000 or 63,000 ports available. For the exact count, you can search on the Wikipedia. There's a lot of information about these port numbers. So with the help of one this public IP address, we can use the around 64,000 users to go to the internet. So this was basically saving the internet. So it was decided that whoever is assigned this public IP address, they will be charged you pay for this public IP address allocation, and the private IP addresses can be used by anyone free of cost. If you are at home, you can use any of the private IP addresses, but in fact you are not in the internet, you can use these public IP addresses as well, because you are at home, you are not exposed to the internet, nobody is stopping, right? Nobody knows that which IP addresses are you are using. So that's what it is about the NAT. So if you observe this time that we are having the three types of NAT. The first one was like static NAT, another was dynamic, and the third type of NAT was NAT overload, and some of the user also call it as a PAT. These are the types of NAT whenever we are translating, like these are the types of translation we can say. But if you observe that it is translating the source IP address, right? Whatever the source IP address was, that was translated. So you can say it was happening a source NAT, because source NAT was translated. But if there is a requirement, and there is sometimes requirement that we translate the destination IP address as well, and that normally happens with the destination server. So this is also available, source NAT and destination NAT. We will learn these as well while doing practicals. Another type of thing, like if you talk about the benefits of NAT, so one of the benefit of NAT, like reusable IP addresses we can say, right? Another thing is like for the security purpose, like whenever there is a NAT, our private IP address is not exposed to the internet, right? So this is an enterprise, I'm using 10.1.1. when I'm going to the internet, if somebody is here, he is just tracking my traffic, like he is not he's a bad guy here, right? So if he is tapping my traffic and he's observing, he will see only my public IP address 20.20.20.20, and if he tries to access my machine, he cannot, right? Because he cannot know, he don't know my private IP address. So another reason of this thing is like security. Third thing, we use at the destination and can be used as a load balancing as well, but that does not no really used. We are having lot of load balancers available, so we take their help. But if you are like a cheap company right, you want to save money, then you can get this thing via the NAT as well. You can do load balancing based on the IP addresses. So this was it about the NAT, and next session I will be covering up about the practical sessions, that how these static dynamic NAT are configured in Palo Alto firewalls, and we will also focus on the source NAT and destination NAT. And if you like all this, just keep in touch with me, and if you have any doubt, reach me anytime. Thank you guys, see you soon, bye bye.